Right now, somewhere in a building you'll never see, a server is running at full power. Fans spinning, lights blinking, electricity pouring in by the megawatt, and it is doing absolutely nothing. No app is loading, no file is being saved, no human is waiting on the other end. It's just on. Burning money, burning power, processing nothing at all. But the real answer for why this happens is far stranger than a forgotten light switch. You assume every server in every data center on Earth is working for someone. That assumption feels obvious. Surely a company would notice if a machine sat there doing nothing, right? But you would be wrong. Spectacularly wrong. There is an entire hidden category of computing called the Comatose server, and it costs the global economy billions of dollars a year. So why would anyone let that happen? To understand it, you have to understand what a server actually is. Not the mysterious cloud some people imagine. A server is a physical computer sitting in a rack inside a warehouse-sized room called a data center. Every time you stream a video, send a message, open an app, a request travels from your phone across the internet and lands on one of these machines. The machine processes it and then sends a response back. Then it waits for the next request. That part makes sense. What does not make sense is what happens to the machines nobody is asking anything of anymore. Here's the strange part. When a company builds an app or a website, engineers spin up a server to run it. Sometimes that project gets canceled or the app gets replaced by a newer version, and everyone simply forgets to turn the old server off. The server doesn't know any of this happens. It just keeps running, keeps drawing power, keeps waiting for requests that will never come again. Jonathan Koomey, a researcher at Stanford University who has spent decades studying the energy use of computing, helped lead a landmark investigation into exactly this problem. Working with the consulting firm Anthesis, his team studied thousands of servers across multiple companies. What they found should unsettle you. Roughly 30% of all servers examined were what researchers now call comatose. Fully powered, fully cooled, doing nothing measurable for 6 months or more. Not failing, not broken, just forgotten. Think about what that means at scale. The world runs on millions of servers. If even a third of them are doing nothing, that is not a small inefficiency. That's an entire shadow industry of wasted electricity, wasted hardware, and wasted money, hiding in plain sight inside every major company on the planet. Doesn't that feel like the kind of thing someone should have caught by now? You might assume this is a problem unique to small, disorganized companies, but the opposite is true. The biggest offenders are often the largest, most sophisticated organizations on Earth. Banks, telecom providers, universities, government agencies, places with thousands of engineers, enormous budgets, and entire departments dedicated to IT infrastructure. You might think the most resource companies would have the cleanest systems. Instead, scale makes the problem worse. The more servers a company owns, the easier it becomes for a handful of them to quietly slip through the cracks, unnoticed, buried under spreadsheets, ownership changes, and years of staff turnover. Nobody designed this outcome, it simply emerged machine by machine, decision by decision, until it became permanent. And the financial weight of it is staggering once you actually calculate it. A single mid-sized server can cost the company several $1,000s a year in just electricity and cooling, even before counting the price of the hardware itself or the floor space it occupies. Multiply that by the estimated millions of comatose servers running across the world's data centers, and you arrive at a number that sounds almost unbelievable. Billions of dollars spent every single year, not on innovation, not on new projects, on machines doing nothing, for no one, that everyone forgot to switch off. But here's the deeper reason this happens, and it has nothing to do with carelessness. It has to do with fear. Turning off a server is terrifying for the people responsible for it, because nobody can ever be completely sure what depends on it. Maybe a tiny internal tool still pings it once a year for a legacy report. Maybe a single client's outdated software still expects it to respond. The cost of being wrong, of breaking something nobody remembers exists, feels far more dangerous than the cost of simply leaving the machine running forever. So companies choose the safer feeling option. They let it hum along, untouched, for years. This is where the engineering deep dive gets genuinely strange. Servers are built for redundancy. Engineers don't build one server to handle a task. They build 2, 3, sometimes 10, so that if one fails, the others absorb the load without anyone noticing an outage. This is good engineering. It keeps your bank app working and your video calls from dropping, but it also creates the perfect hiding spot for waste. In a system built to expect idle backups, an idle server doesn't look suspicious. It looks normal. It blends in with machines that are supposed to be sitting quietly, ready, just in case. Nobody questions a server for being idle, because idle is sometimes exactly what it's supposed to be. There is also a second, quieter layer to this. Inside every server, even a completely idle one, the processor never fully stops working. It runs what engineers call background processes, tiny housekeeping tasks, checking for software updates, logging system health, listening on network ports in case a request arrives. None of these tasks accomplish anything a human actually wants, but they keep the machine technically active, technically alive, technically billable as infrastructure that's in use. A server can sit there for years, never once doing meaningful work, while still appearing on a dashboard somewhere as operational. The very signal companies use to decide whether a machine matters, whether it's on, whether it responds, is also the signal a truly useless machine can fake simply by existing. Now layer on something even more counterintuitive. Even when a server is doing real work, much of its processing power is still wasted. A landmark study published in the Journal of Science in 2020, led by Eric Massenet, an energy researcher then at Northwestern University working in the U.S. Department of Energy's Lawrence Berkeley National Laboratory, examined global data center electricity demand directly. His team found that despite computing workloads roughly quintupling between 2010 and 2018, global data center energy use stayed nearly flat. That sounds like incredible news, and in some ways it is. Engineers genuinely got far more efficient at squeezing computing power out of every watt. But buried inside that same research is a quieter, less comfortable truth. Most individual servers, even the busy ones, still operate well below their maximum efficiency for most of the day, because workloads spike and dip unpredictably, and machines have to sit ready for peaks that may never come. So, you have idle servers no one remembers to shut off. You have busy servers with redundant backups running just in case. And you have entire data centers engineered to handle traffic spikes that might happen once a year, sitting prepared the other 364 days. All of it costs real electricity, real cooling, real money. None of it is visible to you when you open up an app and it simply works. Here's the twist that makes this even stranger. You would assume the solution is obvious. Just audit everything, find the dead servers, turn them off. Companies have tried, many still try. But identifying a Comatose server is shockingly difficult because the tools that monitor server activity often only track surface-level metrics like power draw or basic uptime, not whether the server is doing anything meaningful. A server can look busy on paper while doing essentially nothing of value, simply running background processes that exist to keep the machine alive. The very systems built to monitor waste are sometimes too blunt to actually detect it. The fix for invisible waste requires visibility the infrastructure was never designed to provide. This isn't just a corporate problem hidden in some warehouse far away from you. It's a mirror of something you do every single day. Think about the apps still installed on your phone that you haven't opened in over a year. Think about the email inbox running quiet background syncs for accounts you forgot you even have. Think about browser tabs left open, silently refreshing, silently drawing power long after the moment you needed them has passed. You are, in your own small way, running Comatose servers of your own. Things left switched on, not just because anyone needs them, but because turning them off feels riskier than just leaving them be. Consider your own streaming subscriptions for a moment. Do you have any services that you haven't used in a while? Somewhere, a server is still keeping your account active, still storing your preferences, still ready to greet you the instant you log back on, even though the odds say you might never log back in at all. You didn't forget on purpose, you simply never reached the moment where deleting felt more urgent than ignoring. That's the entire phenomenon, playing out at a human scale instead of a server scale. Multiply your own small forgotten subscriptions by hundreds of millions of people, and you start to see how naturally this same pattern scales up into a billion-dollar industry hiding inside data centers. That's really what this comes down to. Not laziness or stupidity, but a very human reluctance to delete, disconnect, or shut something down, just in case it turns out to matter later. Multiply that instinct across every engineer, in every company, managing every server for the last 3 decades, and you get an invisible global infrastructure quietly burning billions of dollars on nothing at all. Isn't it strange that the most expensive habit in modern computing isn't a flaw in the code? It's the very human fear of letting go. So the next time your phone buzzes, a video loads instantly, or an app responds the moment you tap it, remember what's actually happening behind that screen. Somewhere, a machine is awake and ready just for you. And somewhere else, nearby, another machine just like it is awake too, waiting for a request that stopped coming years ago. Both machines look identical from the outside, both cost the same to keep running, but only one of them is actually doing anything at all. And right now, somewhere in a building you will never see, that other server is still running at full power, still burning electricity, still processing nothing.